Here we're going to begin looking at how to solve equations where these equations contain radical expressions. So to get us started, we need to begin by reviewing the principle of powers. So for this principle, we want to let n be any positive integer. So n is an element of the positive integers, 1, 2, 3, and beyond. Now, the principle of powers tells us the following. So the principle of powers says that if a equals b is true, then a to the n equals b to the n is also true. So what this is telling us is that by raising an equation or both sides of an equation to the same power, we're going to be able to remove any radicals from that expression, thus allowing us to solve. So to help us understand this a little bit better, let's consider the following example. So let's suppose that we're asked to solve for x, and we're given the third root of x is equal to -2. Now, when we're solving an odd root radical, or any radical for that expression, or for that matter, we always want to make a note of the root index. So notice in this case, our root index is 3. So by the principle of powers, in order to solve for x here, we're going to want to raise both sides of this equation to the power of 3. Now notice on the left-hand side, we can actually rewrite this third root in its rational exponent form and say that this is x to the 1/3, which we now have raised to the third power. So notice the 3 in the denominator is going to cancel with the 3 in the numerator, leaving us with x to the first power. So this is leaving us with the third root and the third power cancel each other out, leaving us with x is equal to -2 cubed. Or in other words, we're multiplying -2 together 3 times, which leaves us with -8. Now here we're solving an odd root radical. And odd root radicals or odd indexed radicals do not have extraneous solutions. However, when we're working with even root radicals like the square root, since we know that they're non-negative, we need to be a little bit more careful when solving. So with that, let's take some time now to explore the different cases for even root radicals. Now, since we know that even indexed radicals are non-negative, extraneous solutions may potentially arise when we raise both sides of an equation to an even power. So to help us better understand this, let's consider our familiar friends, the square roots. So in case 1, we're being asked to consider the equation, the square root of x is equal to -2. Now, we of course know that the square root is an even indexed radical, so this is non-negative, it's greater than or equal to 0, but -2 is strictly less than 0. So we have a contradiction here, and this is letting us know that there is no solution to this equation. Now to give us a better, or to help us with intuition for this, we can confirm this conclusion graphically. So thinking about our given equation here, I want to split it up into 2 curves. So we can say y is equal to the square root of x, and we can also consider the graph for y is equal to -2. So let's plot these 2 curves on the coordinate plane and see what happens. So looking at these 2 curves on our coordinate plane, we have the square root function, and then down below the x-axis, we can see the horizontal line for y equals -2. Now, no matter how far we stretch out this horizontal line, this is never going to intersect the square root. So these 2 curves have no intersection, or in other words, no solution. So what about case 2? So again, we know our good old friend, the square root here, is non-negative. So we can say that the square root of x is greater than or equal to 0. And 2 is also greater than 0. So we have a non-negative even root radical and a constant that is positive, so a solution will exist. So let's start here by solving this equation algebraically. So we have the square root of x is equal to positive 2, and our index here is 2. So to solve for x, we're going to square both sides of the equation, which leaves us with x is equal to 4. Now, again, here we've solved to find the solution algebraically, but we can also confirm our conclusion here graphically by splitting this into two curves. So just like we did with case 1, I'm going to let the first curve, y, be the square root of x, and we'll let our second curve be positive 2. Now, we already have the square root up on our graph. Now, drawing a horizontal line for y is equal to 2, observe here that the first intersection of these two curves occurs when x is 4 and y is 2, thus confirming the answer we found below algebraically. So big conclusions here. Even root radicals or even index radicals are non-negative. If we have an even root radical equal to a negative value, there's no solution. However, if we have a positive or an even root radical equaling a positive constant, we can proceed in solving for x. So now that we have established some intuition for these different types of radical equations, let's build some strategy for solving radical equations. So step 1. So the first step is to simply isolate the radical. Now, keep in mind that if an equation has two distinct radicals, then all we need to do is simply choose one of those radicals and isolate it. So for example, let's suppose that we have the square root of x plus 1 minus the square root of x plus 2 is equal to 7. So this radical equation has two distinct square roots. So I can simply pick either one and isolate it on one side. Now here, I've isolated the square root of x plus 1, but keep in mind that you could have equivalently isolated the square root of x plus 2. Now step 2. So in step 2, we apply the principle of powers. In other words, we want to raise both sides of the equation to the same power as the radicals or the index of the radical. So for example, if we think back to this equation here, that means that we're going to want to raise both sides of this equation to the power of 2. Now be careful here. On the left-hand side, our square root and the square are going to cancel each other out, leaving us with x plus 1. However, on the right-hand side, we have the sum of two terms. So this means that we are going to have to FOIL this product out. This can be rewritten as the square root of x plus 2 plus 7 multiplied by the square root of x plus 2 plus 7. So now that we've expanded that out, we'll need to FOIL this in order to solve for x. So just be careful when working with equations that have two distinct radicals. Now step 3. Now step 3, solve the equation. But keep in mind, if your equation still contains a radical, don't give up. You simply have to repeat steps 1 and 2 to remove the radical. So that's going to be the case in this example. After we FOIL this out, our equation will still contain a radical, so we'll need to repeat steps 1 and 2 to remove it. And last but certainly not least, we need to check our work. So we want to check our potential solutions by substituting each value back into the original equation to make sure that it's satisfied. Now, we need to remember that even root radicals are non-negative. So extraneous solutions may arise when we raise both sides of the equation to an even power. So those definitely need to be checked. Now, while en route radicals do not have extraneous solutions, I still encourage you to check your work. It's always a good idea.